Can you hear me, Akshat?
I can hear you.
Okay, let's start then. So, today we will be discussing, as we have nominated is completed, creation is, even classification is also being completed, creation, physical property, tree, properties between physical properties. Okay, these are already being completed. So today we will start our chemical properties. Here now we will discuss about chemical reaction of haloalkane. So basically
Are you
mainly three
sharing
types.
screen?
Yeah?
Are you sharing your screen? I can't see anything.
I think I haven't seen. I think I have forgotten. So is the screen visible now? Can you see the
Yeah, I can see.
chemical reactions of haloalkanes are broadly classified as first nucleophilic substitution, which needs to be more focused, then elimination, then reaction with metal. Substitution reactions are classified as SN1 and SN2. Okay, so first of all we will discuss here nucleophilic substitution reaction. Nucleophilic substitution reaction. Before moving to that, tell me what is nucleophile? What
Uh,
is
nucleus level.
nucleus loving, or we can say
It donates tendency to donate electrons.
the nucleophile are species which are electron rich. Okay. So there are nucleophiles like OH minus, so negative nucleophile, and some nucleophile is like this NH3. How this NH3 comes out to be nucleophile? Because the nitrogen has lone pair. As the number of valence electron in nitrogen is 5, so 3 it uses 3 electrons to make a bond with hydrogen. Okay,
Yeah.
this way it can complete. um, it can complete its octet since 5 electrons. So this is its lone pair. Okay, so when a nucleophile donates its electron from its lone pair, it is known as neutral
Nucleus.
nucleus. Or else these are like OH minus, CN minus, they are negatively charged nucleophiles. Now, as nucleophiles, this is the denotation of nucleophile, are electron rich, so it will attack a place where it is electron deficient because opposite charges attract each other. Place where it is electron deficient. Understood?
Yeah.
Okay. Now, suppose this is your alkyl halide. Okay, and nucleophile, let it be this is your nucleophile. It can be Cn minus, can be OH minus. Now, which is the most polar bond? Polar bond, do you understand? We have discussed earlier also. Polar bond. Which is the most polar bond? Or
Second.
if this, like if A, B, I have written, which one is your most polar bond?
A.
A, right? Because it is directly connected to halogen. It withdraws
Halogen.
it withdraws electron from the carbon, creating partial negative charge on chlorine and partial positive charge on carbon. So this nucleophile will attack on this carbon as it is substitution, means in place of one, other will attack, other will join, and the next one will leave. So here nucleophile attacks the electrophilic center, and this halogen leaves out as leaving group. So the product will be like CH3, CH2, nucleophile plus Cl minus. Okay, understood? New substitution
Yeah.
means what? Replacement, right? Here, nucleophile is replacing the halogen atom. Why the halogen atom is being replaced? Because if it will get this electron and get away, it will get stable configuration. Like Cl has 7 electrons, right? And minus has 8 electrons. So which one is more stable?
Cl minus.
Minus. Like if it gets a chance to get its octet complete, so it will easily remove. That's why Cl leaves the compound easily as group, and this nucleophile gets attached to that electrophilic carbon. So this is the whole process of nucleophilic substitution reaction. Like now, like if this is nucleophilic substitution reaction, there should be some chemicals which provide nucleophile. Okay, so reagents which provide nucleophile are as follows. Okay, so if you have the NCERT book with you, go for page number 300. Page number 300. 300.
Yeah.
If you are taking here it is not mentioned aqueous, but you need to use aqueous word, because if it is only NaOH, alcoholic KOH or NaOH gives other letter. If it is aqueous NaOH, so we can associate it as Na plus OH minus.
OH minus.
So which one will be your nucleophile then?
OH
OH,
minus.
OH minus. So if you are carrying out some reaction like CH3, CH2, Cl plus NaOH, your reaction. So what will be the product?
CH3, CH2,
Uh,
Na.
so
No.
not Na,
Wait. OH.
OH, and Cl minus will be removing here, moving
Oh
here and
yeah.
there. Plus will moving here and there. So it will make Na, Cl as
Cl.
side product. Okay, side product. So this is your main product. So whenever alkyl halide is get reacted with aqueous NaOH, or same reaction goes with KOH. aqueous NaOH or KOH, it gives alcohol. So it can be a conversion also. How will you convert alkyl halide to alcohol? You can easily convert it by reaction with aqueous NaOH. Got it?
Yes.
Okay.
Yeah.
Now, in a similar way, if I provide you a reagent H2O, what will be your nucleophile?
O minus.
OH. Whenever you dissociate water, it comes out as H plus,
Yeah.
and
H plus
their
OH
nucleophile.
minus.
Yeah. So you can get OH nucleophile from both the reagents, that is from aqueous NaOH or KOH as well as H2O. So if Rx is your reactant or alkyl halide, if you react with water, what product will you get?
OH.
ROH.
X. Yeah.
Okay. So or plus HX will be your product.
X.
Okay. So here actually in water OH minus I am saying, but actually water is providing nucleophile from the lone pair of oxygen. This is a neutral nucleophile. It don't come out as this. Okay. This for explanation purpose, it is easy to explain that OH is getting attached to the alkyl group. That's why I use it. But in reality, lone pair of oxygen. Okay, it's something like this. Okay, let me explain the mechanism. If R is partial positive charge and X is partial negative charge. So water is there, this was like this. So this will donate electrons like this one, R, and X will leave away. So O, H, and H. Since oxygen can make only two bonds, so there will be a formal charge, positive formal charge. So it will remove one H easily so that it can get stable as ROH. And this H plus is moving around with X minus, it will form HF. Got it?
Yeah.
Let's move to the third nucleophile, NaOR dash. It is known as metal alpha oxide. Alkyl group is there R, oxygen is there, so it is known as sodium. You are taking sodium alpha oxide. So now tell me what will be the nucleophile?
OR minus. OR.
Yeah, what? Okay, and now similar way. Okay, so when you are reacting this with RF, NaOR, what will be your product? NaOR dash. What will be your product?
R.
R O
OR
R dash
plus. Yeah, R dash
plus
plus
NaX.
NaX.
So this functional group is known as ether. Ether. Okay. NaI.
Sodium iodide.
So your nucleophile will be
I.
I minus.
I
Okay.
minus.
So R
R.
plus NaI will give you
NaI. Ri plus
Ri
Na.
NaX.
NaX.
Have you seen reaction earlier?
What?
Have you seen this reaction earlier in this chapter?
I would have, but I forgot.
Yes, we had. In
Maybe.
Finkelstein reaction. Remember? Halogen exchange
Oil.
reaction. Do you remember?
Yes, I remember.
In that. So that's why I mentioned it again. Okay. Next nucleophile. NH3. Just we have discussed few minutes back. Right? Now nitrogen will donate electrons from its lone pair as it is neutral nucleophile.
Substitution.
Yeah.
Nucleus.
If Rx is there, look, just like water, it will form. Acha. Can you tell me the valency of nitrogen?
1.
Valency of nitrogen is 1. How can it be?
No,
What is
no, wait. So 5.
okay? Let me valence electron is 5. Okay. So how many electrons will it
3.
require? 3. So valency is 3. Okay.
Oh,
Valency is, that means it can get stable by forming bond. If it is forming more than that, then it will attain a positive charge over it, just like the oxygen. Can you tell me the valency of oxygen?
oxygen atomic number is 8.
Valence
2 will
electron is,
be the one.
yeah. So when oxygen is forming more than 2 bonds, it will attain positive charge.
Will positive charge.
So if this is the case, look, R N H3, it will form like this, and X minus is moving here and there. So how many bonds did nitrogen form?
3.
Look the compound carefully and tell me how many bonds nitrogen has formed with how many
4.
hydrogen bonds? 1, 2,
Hydrogen
3,
3 bonds.
and
And
one with
yeah, so 4.
4. So how many extra bonds does it have made other than its capability? Extra one, so
1.
one positive charge. So in that case, it will remove one H plus. Okay, it will take this electron and H plus will be released. So it will become R N H, and if H plus is moving, this will form a bond as HX. Okay, so now we can say that when ammonia is reacting with alkyl halide, we are getting RNH2, that is your amine. Okay, and this nitrogen is directly bonded to only one carbon, so it is known as primary amine. Got it?
Yeah.
Did you understand?
Yes.
Okay. In a similar way, if I provide you RNH2 as reagent, like I am providing you primary amine as your reagent. So in a similar way, can you tell me the product if that is the R dash? If Rx is reacting with RNH2, what will be the product?
RNH.
RNH. R dash NH, right? Whenever you are doing this, let me help you with a trick.
What does R dash mean?
Like if this is CH3, this is C2H5. Like both the alkyl groups are different. just to make you identify. One it is attached to alkyl halide, another one is attached to amine. Just to differentiate. Okay, okay. Let me help you with the above one. R X is there if NH3 is there. Okay, remove HF. What product will you get? RNH2, isn't it?
Yeah.
In a similar way, if Rx is there, N S H R dash. So remove HF. What product will you get?
R and NH2 plus HX.
NH2 or only NH?
NH.
R N H R dash plus HF. Right. So this nitrogen is directly connected to how many carbons?
Carbons.
Two carbons. And this R is
Two
alkyl group,
carbons.
na?
Yeah.
Yeah. So whenever primary amine reacts with alkyl halide, it gives a secondary amine. Okay. In a similar way, if I provide you R dash R double dash NH, like these are different, plus Rx, what will be your product? If you have understood the above two, you can answer this one. Just remove HF.
R R dash and N R double dash, then H will be in plus
Yeah,
HX.
plus HF. So what is the degree of amine?
3.
3 degree, right? So your product will be R from here, N, R dash, R double dash plus H. So it results in your tertiary amine. These three reactions which we just read now, you will read it again in chapter amine. Okay, in amine, we study as ammonolysis. Okay, remember this. Amine, this is the last chapter of organic, where we study this. Why will we do for preparation of amine? Okay, so these are the nucleotides which we discussed. Other than this kind of nucleophile, we also have some special nucleophiles which have some special features. Like if we are giving you KCN, the nucleophile will be what will
Cl.
be the CN minus.
Yeah, Cl minus.
So in that case, C is provided. If if I am giving you AgCN, again you will say CN, but
Yeah.
at this time when you are taking AgCN, nitrogen will be donor. The negative charge will be on nitrogen. So such kind of nucleophiles are known as ambident nucleophiles. Okay. Which have donor site, but donate from only one site at a time. Got it?
Yeah.
Whenever we will be using KCN, CN will be your donor site. Whenever you will be using AgCN, nitrogen will be your donor site.
Donor
So
site.
cyanide nucleophile is termed as ambident nucleophile. Okay. Now, if I am taking Rx plus KCN, so your product will be RCN.
RCN.
Okay. So this is known as nitrile, or some people used to say it as cyanide. On the other half, if you are taking AgCN, can you name the product? R. Who will be the donating site?
Nitrogen.
Nitrogen. So it will be MC, not CN. Okay.
Okay.
This is known as isonitrile. Got it?
Yeah.
In your syllabus, two ambident nucleophiles are there. One is CN, other one is NO2. Let's discuss about that as well. If you are using KNO2, NO2 is your nucleophile, but oxygen will be your donor site. For NO2, oxygen donor. But if you take AgNO2, your donor site will be
Nitrogen.
F. One single one. N will be your donor site. It will donate from N. So if Rx plus KNO2, your product will be RONO plus KX. Okay, so this is known as alkyl nitrite. And if I am using Rx plus AgNO2, can you tell me the product?
Mm.
Can you tell me the
RN
RNO2
and O2.
plus what will be the side product?
Uh, RNO2.
Why? It is your main product, RNO2. Side product will be AgX.
AgX.
Okay. So this is known as nitroalkene. Okay. Even this ambident nucleophile, you will read again as ambident ligand in coordination compound. Okay. So these are the common nucleophiles and ambident nucleophiles which we will go through this chapter many times. Other than this, like if I am providing you R-COOAG, what will be the nucleophile if this is your reagent? whenever you see any metal in your reagent, remove that one.
AG.
Ag, how can Ag be Ag is a metal. Ag will get a positive like just NaOH you are taking, Na plus is positive charge. It cannot be amplified. Removing the metal, whatever is left, that becomes your
CO.
R dash COO minus becomes your nucleophile. So whenever any alkyl halide is reacting with R dash O, Ag, what will be the product?
And AG. C2.
R, this minus charge will attach first, COO, it will be like this, bond, C double bond O, R dash. This is your,
Plus AG.
okay, this is your ester. Okay, next one, lithium aluminum hydride. It is lithium aluminum hydride. You will also read it as in the upcoming chapters, reducing agent. Lithium aluminum hydride means reducing agent. Okay. Like can you hear me, Akshat? It got disconnected by its own.
I can hear you.
Okay. If this is the question, can you tell me the product?
CH3, CH2.
CH3,
A.
CH2 then? Whenever lithium hydride is there, this will get attached, right?
Yeah.
So it comes out as CH3, CH3. Can you name this compound?
Dimethyl.
Okay, let's go again to the PRS. Prefix, root word, suffix. Is there any prefix? No. How many carbons are there?
2.
2. For 2, what is the root word for 2?
Di.
Di.
Oh no.
One,
Ethyl.
2, it.
Dimethyl
Right?
ethyl.
Yes, it will be 1, 2 carbon. It will be the word and they are attached with single bond. So it will be ethane. Why are you making things complicated? Simple, na? 2 carbons are there, all are attached with single bond. It will be simple ethane. Right? So here it was, prefix was there, chloro. Okay. How many carbon? 1, 2. So 1 chloroethane. Right? Okay. Understood?
Yeah.
So let's move ahead then. Can you tell me the product?
OH minus Na. Na. So OH minus will attach to the cyclohexane.
Which position? This Cl will be replaced, right?
Yeah.
So it will be like this. Okay. So what would be the name of this compound?
Uh, Phenol.
No. When phenol is when benzene is there to it, OH is attached. That is phenol.
Okay. So
It is
2-cyclohexane.
cyclohexane.
Uh,
It would be
hexane.
if,
The
extra nol,
cyclohexane 2.
one all.
Okay.
If only one is there, why will you go for two? The smallest number should be given, right? When you are
Yeah.
writing the nomenclature, it is okay. Let's try. Okay, tell me the product.
CH3 NH2 plus HCl.
Right. CH3 NH2 plus HCl. So it would what would be the name? The functional group NH2 amine. One carbon is there. It is known as methanamine.
Methane.
Okay, methanamine. Single bonds are there. So methanamine. So what is the degree of this amine? Nitrogen is connected to how many carbons? Directly.
Uh, 1.
So it
Not
is
connected to
trimethylene.
any
I
primary.
told you, na? this is we must. This is like this.
Yeah.
We write it in this way. Okay. Now tell me the product.
CH3, CH2, H will come down plus NABI.
Yeah. CH3, CH2, O, CH3, and NABR is your side product, right? So this is which functional group? I just told it is ether. Now,
Ether.
so whenever you will write the IUPAC name during the ether functional group, follow this rule. In which side of oxygen do you find the maximum number of carbon? Left side or right side?
Left.
Left side, right? So this is your parent chain. Okay, and this comes out your daughter chain. So the daughter named as one carbon is known as meth for one carbon, and for oxygen it is written as methoxy. And here two carbons are there, so each single bond ethane. So the name of this compound would be methoxy ethane. Got it?
Yeah.
Okay. Next, if you have understood, try to name this one. What will be the product?
1 second. CH3, CH2, then OCH2, CH3 plus
Right.
NAI.
Plus NABR.
NABR.
Sorry. NAI.
Yeah.
Right. Now, both of the sides have equal number of carbons. So you can make either of the chain as parent
Parent
and
chain.
either. So both are having. So what would be the for two carbon? Which root word do we use?
Ethylene.
It, right? It, then oxy,
Ethoxy.
let
With
two carbon.
ethane.
So this is your parent, this is your daughter, two carbon ethoxy and two carbon here, and the parent ethane.
Okay.
Now, I hope you have understood how to get the product if a nucleophile is
What?
Did you understand how to get the
Yeah,
product?
yeah,
I
I
am not
understand.
all the examples, but I hope you can go with other examples as well.
No,
Okay,
yeah,
so let's talk more about this nucleophilic substitution, that new topic, that is SN1 and SN2. Okay. Now, suppose you are staying, as you are staying in Bangalore, you are going to Kolkata. What are the options? How can you go? You can go by air, you can go by train.
land. Yeah,
Okay. But you cannot go by sea. There is no option to go Kolkata by sea. Okay. So, if these
yeah.
are the two options, ultimately you will reach Kolkata, right?
Yes.
In a similar way,
If I
like
go
with
in one way, it will be SN2. If I use different transports, it will be SN1. Two
no,
transports.
no, no. It's not like that. Suppose if you are using, so which one will you choose? It depends upon your situation. Suppose if it is urgent and you have money as well, so which
Yeah.
route will you take? Situation. These are your situations. Okay. And if you have sufficient amount of time, but you are having lack of money, which one will you
Train.
prefer? You will prefer train. So depending upon the, in both the cases, ultimately you will reach your destination, right? So
Yes.
depending upon the situation, which path will you choose? That is your S1 and S2. Depend,
Okay.
like both SN1 and SN2 will give you substitution reaction. Only difference is that depending upon the situation, what are those situations we will discuss. Depending upon the situation, it will choose a pathway, either SN1 or SN.
SN2.
Okay. Now let me discuss a little bit about the mechanism, so that it will help you, the alkyl halide or the nucleophile which I have given you, to decide which pathway it will choose. Okay. Generally, we go for SN2 first, so that it is easier to understand SN1. Whenever we are talking SN2, it means nucleophilic
Substitution.
substitution.
Reaction.
No, and 2 refers for bimolecular.
Oh,
Okay. Do you remember in chemical kinetics we have studied the molecularity of reaction, unimolecular, bimolecular?
yeah.
Or at that time, what does this mean, bimolecular?
If molecularity is 2, it is my bimolecular.
What do you mean by molecularity of
Uh,
two
I don't know
molecules?
to explain.
Two
Yeah.
molecules are taking.
2
Okay.
molecules.
So in a similar way, SN1 refers for nucleophilic substitution unimolecular. That is
Unimolecular.
one molecule will be the deciding factor of the reaction. Okay, let's start. In SN2, suppose is your alkyl halide. Okay. Can you tell me the hybridization of this carbon? We have discussed very beginning, in the very beginning. If it is forming 4 sigma bond, that means the hybridization would be
sp3.
sp3. Do you know the geometry of sp3? Like what will be the structure of the compound if the carbon is having sp3? Somewhat tetrahedral.
It's some difficult name.
Tetrahedral. Okay, tetrahedral. And how
Yeah.
does it look? It look like this. See, like this. Just like a pyramid kind of structure. Okay, like this. But
Yeah.
we will not go into detail about that. Let's discuss SN2 first. So, if halogen is attached, your teacher must have said above the plane, below the plane, which would be difficult to discuss here. But let it be. I will send you the 3D images so that it will be helpful. So, if OH minus is your nucleophile, in case of SN2, the nucleophile attacks the electrophilic center and this leaving group halogen, these two processes take place simultaneously. What are the two processes? Attack of nucleophile and leaving of halide, halogen. And here halogen is considered to be the leaving group. So this simultaneously takes place simultaneously. Okay. But in case of SN1, the two processes take place in a different pathway. First, first step, leaving group leaves. So if the leaving group is leaving, it is generating carbocation. Okay.
Yeah.
In the second step, attack of nucleophile.
Nucleophile.
Now, if it is a carbocation, nucleophile will attach here and formation of product RCR nucleophile state. Now, one may ask at what condition it will be SN1 and at what condition it will be SN2. Now,
SN2 if it's single step, SN1 if it's two step.
But in the both the process, their substitution is taking place. Now, let me provide you an example. If this is your alkyl halide and I am providing you NaOH, aqueous NaOH let it be, and I ask you which pathway will it choose SN1 or SN2? This is my question. So how will you answer? Look. Now you look for the electrophilic center. This one. This is attached to 3 group.
3.
If it is, suppose let it be going through SN2. This nucleophile, for this nucleophile, it is difficult to get there because 3 groups are blocking. If it is following SN2, the nucleophile will attach directly and leaving group will leave. But as the center is crowded, it will be difficult for the nucleophile to reach there. So the
Yeah.
situation is not favoring for SN2. So rather, if we will go for SN1, it will first remove the leaving group, generate carbocation, right? And if this is happening, then the nucleophile will get space to reach the carbocation. So, can you tell me now whether this alkyl halide will choose pathway SN1 or SN2? Which pathway will it choose? Can you hear me, Akshat?
I can hear you.
Like which pathway which will choose?
Your voice is breaking.
Just for a minute, we are about to end our class. Like I am asking you which pathway it will choose, SN1 or SN2?
SN1.
SN1 because it is bulkier. The carbocation will bulkier. So whenever the alkyl halide is 3 degree, it will prefer SN1, and whenever it is 1 degree, it will prefer SN2.
SN2. When
Okay.
it's 2 degree?
That time we will do, there are few more factors which will decide. Okay. So
Okay.
for the time we will end it over here. In the next session, we will discuss more about this SN1 and SN2. Okay.
Yeah.
So that's all for today. Again tomorrow we will meet on Sunday.
Okay.
You can leave the session.